Hey guys, Mr. Backerberg here. In this video, we're going to look at solving a system of linear equations by graphing. When we're looking at solving a linear system by graphing, what's going to happen is we're going to be given two equations, and we're going to be looking for a solution that satisfies both of those equations. When we're doing so graphically, what we're going to do is go ahead and graph out each equation on the same set of axes. And what we should notice is that our two lines are going to cross at a specific point. And what we want to do is identify the coordinates of that intersection point. Wherever your two lines intersect, that point is going to be your solution to the system of equations. So as we're looking at this first example, we're given the equations y equals x minus 7 and y equals negative 1/4 x minus 2. And we're going to solve this system by graphing out each equation and finding the intersection point. Both of these equations are written in slope-intercept form. And remember, slope-intercept form looks like y equals mx plus b. And having equations written out in slope-intercept form is nice because it gives you the information that you need in order to draw a graph quickly. The b value on the end stands for your y-intercept, and the m value in front of the x, that's your slope. So as we look at this first equation, y equals x minus 7, I see that there's a negative 7 as the b value on the end, meaning that our graph is going to cross through the y-axis at negative 7. So from the origin, I can count down 7 spaces and put my first dot there. Now as I look in front of the x, there's no number written in front of the x, which means there's an implied 1 in front of there. So the slope of this equation is 1. And we always like to think about slope as a fraction, and we can turn any whole number into a fraction by putting it over 1. And then with the slope, we've always thought about that as being rise over run. So we're going to rise 1 space and run to the right 1 space as well. So from that y-intercept that we just plotted out, I'm going to go up 1, over 1, and I'm going to do that a few times to give me multiple points that I can use to help me draw in a nice straight line. So there's my graph for that first equation. Now I'm going to look at my second equation over here in blue, y equals negative 1/4 x minus 2, and I'm going to do the exact same thing. I look on the end and I see a b value of negative 2. So from the origin, I'm going to go down 2 spaces and put my first dot. Now we've got a slope of negative 1/4. So if we think about rise over run, the negative 1 means we're supposed to go down 1 space and then to the right 4 spaces. And I'm going to do that a couple of times to give myself a few points to plot out to be able to draw in my second line. So I now have both of my equations graphed out on the same axes. That was our first step. Our second step was to identify the coordinates of the point where our two lines intersect. So we can see that our two lines intersect at this point right here. So if we look at identifying its coordinates from the origin, it's 1, 2, 3, 4 spaces to the right. So it's got an x value of 4. And it's down 1, 2, 3 spaces. So it's got a y value of negative 3. So the solution to this system of equations is the point 4, negative 3. In our next example, we've got the equations y equals 5x and y equals negative 5x plus 10. And the very first thing that we're going to do is graph out both of our equations. So I'm going to start with this equation on the left here, y equals 5x. It's written in slope-intercept form, so I'm going to look to identify the b value as far as the y-intercept and the m value for the slope and use those to help me graph this out. Now this one doesn't have a b value being added or subtracted on the end. And when that happens, that means that our line is going to cross directly through the origin where our x and y axes meet up. Now, as far as the slope goes, the slope is 5, and I'm going to take that 5 and put it over 1 so that we can see it as a fraction. That way we can think about the rise being 5 and the run being 1. So from this first point that I plotted out, I want to go up 5 spaces and to the right 1 space, and I'm going to do that a couple of times so that I have multiple points to help me in drawing out my first line. So I've got my first equation plotted out. Now I'm going to move on to the other equation, y equals negative 5x plus 10. For this one, I see a b value of 10, so I'm going to go up 10 spaces from the origin and put my first dot. I see that the slope is -5, and I'm going to take that and put it over 1. So from that first dot, the rise is -5, so we have to go down 5 spaces and to the right 1 space. And I'm going to do that a couple of times, again, to help me in drawing out my nice straight line. So we've got step 1 taken care of. Step 1 was to graph out both of your equations on the same axes. Step 2 is to look for where they intersect. So I can see these two lines intersecting at this point right here. And I want to identify the coordinates of that intersection point because that point is your solution. So as you look at what's happening, it's to the right 1 space from the origin. So it's got an x value of 1 and it's up 5 spaces. So the solution point is the point 1, 5. Now, as we take a look at this example, the very first thing that I want you to notice is that these equations are not written in slope-intercept form. They don't look like y equals mx plus b. These are written in what's called standard form. So the process that we're going to use to graph these out is a little bit different. To graph out equations in standard form, what we're going to find are the x and y intercepts for each equation. That's going to give us 2 points to plot out, and we'll be able to use those 2 points to help us draw a nice straight line. So I'm going to start by looking at this one on the left-hand side, where we've got -x plus y equals -5. To find the x-intercept, what we're going to do is plug in 0 for the y value. So when we do that, we're going to get -x plus 0 equals -5. Now when we take -x and add 0 to it, we just get -x. So we get -x equals -5. We want to get x alone, so we want to get rid of that negative that's in front of the x. So what we're going to do is divide everything in here by -1. So that gives us x equals 5. Now this is actually a point. We've got an ordered pair here. We know that the x value is 5 from having x equals 5. And we got that answer by putting 0 in for y. So the y value here is 0. So the first point I'm going to plot out is 5, 0. So from the origin, I need to go to the right 5 spaces, and I'll put that dot. The next point we're going to find is the y-intercept. And in order to find the y-intercept, it's going to be similar to what we did before, but we're going to plug in 0 for the x value. So when we do that, we're going to get -0 plus y equals -5. Now, -0 is really just 0, and if we add 0 to y, we just get y equals -5. And again, this is a point. This is an ordered pair. We've got a y value of -5, so I'm going to put that in the y position, and we got that answer by plugging 0 in for the x value. So in the x position, I'm going to put a 0 there. So we've got the point 0, -5 that we're going to plot out. So from the origin, I need to go down 5 spaces to plot out that point. And now that I've got these 2 points, I should be able to draw in a nice straight line. Now we're going to look at this other equation, 3x plus y equals 3. And we're going to start exactly like we did before with finding the x-intercept. And remember, we did that by plugging in 0 for the y value. So when we do that here, we're going to get 3x plus 0 equals 3. When we take 3x and add 0 to that, that's just going to stay as 3x. So we get 3x equals 3. We want x to be alone. We've got this 3 in front right now. So to get rid of that 3, we're going to have to divide both sides by 3, leaving us with x equals 1. So remember, this is an ordered pair. The x value is 1, and we got that answer by plugging in 0 for the y value. So we've got the point 1, 0. So from the origin, I'm going to go to the right 1 space and put that dot. Now, as far as finding the y-intercept, just like we did earlier, we find the y-intercept by plugging 0 in for the x value. So this is going to say 3 times 0 plus y equals 3. Well, 3 times 0 is 0. And if we add 0 to y, then we just get y equals 3. And again, this is an ordered pair. We've got y equals 3, so that's the y value for the point. And we got that answer by plugging in 0 for the x value. So I'm going to put 0 in the x position. So we're going to plot this out, 0, 3. From the origin, we need to go up 3 spaces and put that point there. Now that I've got these 2 points, I should be able to use them to draw in a nice straight line. So we've taken care of step 1, where we graphed out both of our equations. Step 2 says that we're supposed to look for the point where they intersect, where they cross each other. So these two lines are crossing at this point right here. So we want to identify its coordinates. From the origin, it's to the right 2 spaces, so it's got an x value of 2, and it's down 3 spaces, so it's got a y value of -3. So the solution point is the point 2, -3. We do have one other option that we can use if we've got equations written in standard form, so not in slope-intercept form. One thing that we could do is rearrange them to get them in slope-intercept form. So as we look at that equation in red in the top left-hand corner, we've got x plus y equals -1. If we want to get our equation written in y equals mx plus b form, then we would be looking at that x on the left-hand side and moving it over to the right-hand side. So in order to get rid of that positive x, we are going to subtract x on both sides of our equation. So that's going to leave me with y equals -x minus 1. So then I can use what I know about slope-intercept form to help me graph out this line. So the first thing I see is that we've got a b value of -1, meaning that the y-intercept is going to be at -1. So I'm going to plot that point out. As far as our slope goes, we've got negative x, so what that really means is -1x. And as far as the slope goes, we've always thought about slope as being rise over run. So I'm going to take that -1 and put it over 1 so that we can see the fraction happening. So that means from that first point that we drew out, we're supposed to go down 1 space and to the right 1 space to put our next dot. Then I can use those 2 dots to help me draw a nice straight line. So there's my graph for the red equation. Now, as we're looking at this blue equation over here on the right-hand side, the first thing I see is that 3x, and it's a positive 3x. So to get rid of a positive 3x, we're going to have to subtract 3x on both sides of our equation. So then this is going to say -2y equals -3x plus 12. Next thing we want to do is get rid of that -2 that's in front of the y. Right now, this is saying -2 times y. So to get rid of that multiplication, we're going to divide everything in this equation by -2. So that's going to leave us with y equals, now when we take -3 divided by -2, those negatives are going to cancel each other out, so we're going to get positive 3/2 x. And when I take 12 and divide that by -2, I'm going to get -6. So I'm going to look at that b value first. So we've got -6. So from the origin, we're going to go down 6 spaces and put our first dot. Then the slope is 3/2, rise over run. We've got a rise of 3 and a run of 2. So from that dot, we're supposed to go up 3 spaces and to the right 2 spaces. And then I should be able to use those 2 points to help me draw out a nice straight line. Now, just like we said before, when we graph out our 2 lines, we're looking for the point where our 2 lines intersect. So they're crossing at this point right here. Looks like it's to the right 2 spaces and down 3 spaces. So that would be the ordered pair 2, -3. So that point is the solution to this system of equations. That's going to be it for this video. Thanks for watching.